Good day, everyone. Welcome back to Math 30-2. We're going to be looking at Lesson 3 today in your workbook, which is titled Venn Diagrams Part 1. We're going to continue to learn about Venn diagrams tomorrow. What we've been doing so far is learning about set theory in terms of pairs of sets and what it means to say set A and B or set A or B. And we're going to review all of that in a second. We've also learned that the word not in set theory means the complement of something, or is called the complement of something, and it's just the opposite of that thing. So we're going to be looking at Venn diagrams, using them as what we can call a visual tool to help us solve problems more efficiently. Many of the questions we've been solving in the previous couple of lessons are ones that were not necessarily difficult, but they took a long time because we had to list all of the elements of sets and compare one list to another list. And had we known how to use Venn diagrams, we would have been able to solve those problems much more efficiently. So let's do a bit of review here first. If I go back and look at, I think it's class example 2 from the last lesson, consider the following two sets, A and B, where the universal set is the set of all natural numbers less than 20. Set A are the numbers in the universal set that are divisible by 3. Set B is a set that includes all of the elements that are divisible by 5. And then we're asked to use appropriate notation and list the numbers that are in each of these sets. So what are the numbers that are in set A? Well, those are numbers that are in the universal set that are divisible by 3. So they're multiples of 3. Set A will include, and this is the proper notation, 3, 6, 9, 12, 15, and 18. And we stop there because they have to be natural numbers less than 20. In set B, these are the numbers that are divisible by 5 in the universal set. In other words, they're multiples of 5, so that would be 5, 10, and 15. When we talk about the numbers that are divisible by 3 and 5, the proper notation is A and B, or what we call the intersection. But this means A and B. Whether we use that symbol or not, the meaning is clear. This is the set of numbers that are in both set A and set B. And when you look at set A and B, there's only one number that's in both sets. 15 is the only number in set A and set B. So the intersection of A and B is the set that includes the number 15, and that's it. Now, what about divisible by 3 or 5? I'll remind you that this includes all of the numbers divisible by 3. It includes all of the numbers divisible by 5, and it includes all of the numbers divisible by both 3 and 5. What it is a union of A and B. It's like a union or a marriage of two people, person A and person B, and they have all of these things that they bring into the marriage. A brings in 3, 6, 9, 12, 15, and 18. B brings in 5, 10, and 15. So what is the union of A and B? So this means A or B. Well, it's a set of numbers that are in either of these or both of these. So 3, 5, I'm just putting them in numerical order, 6, 9, 10, 12, 15, and 18, and I'll double check all of that. So are all of B's pieces included? 5, 10, and 15, yes. Are all of A's included? 3, 6, 9, 12, 15, and 18. Yes. So those are all of the elements in the union of A and B. And again, I have to stop doing that. I say the union of A and B, and I guess that's what we would call it, but I use the word and in there. The union of A and B. I don't mean A and B, I mean the union of set A with set B. All right, so now let's talk about a Venn diagram. Everything that we have talked about here in these 4 sets is indicated by this diagram. This is called a Venn diagram. And we're going to dissect this. Notice that I've got a circle that is circle A, a circle that is circle B. The whole thing is in a rectangle, and the rectangle is U. U is the universal set. So anything inside of that rectangle is part of the universal set. 5 is in that rectangle. 7 is in that rectangle. 3 is, 12 is, 16 is. And if you were to look at all of these numbers, every single number here, 1 is inside the rectangle, 2 is in here, 3 is in here, 4 is, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All of the elements of the universal set are in that rectangle. Now, some of them happen to also be inside of circle A, and some of them happen to be inside of circle B. Some of them are inside of circle B, but not inside of circle A. Before I dissect this further, I want to make note or talk about what this is telling you. When you have a number written in a Venn diagram, and let me get rid of some of this now. When you have a number written in a Venn diagram like, I don't know, say this 11, and there's that dot after the 11. You can call it a period if you like. That's telling you that the item is the number 11. Later on, we'll see that if there is no dot, then the number is telling you how many items are in that region. And you'll get used to that. But when you're loading elements that are numerical, like the number 1 or the number 17 or 15, you have to put a dot after them. Okay, note the following points. The number divisible by 5 and by 3 is located in the intersection. So this is interesting. Well, I think it's interesting. When you go back and you take a look at the bottom left corner of the screen here, A and B had only one element, and it was 15, and we call that the intersection of A and B. Well, look at where the 15 is written. It's written where circle A intersects circle B. It's the overlap. The numbers divisible by, so maybe I want to highlight something here. The intersection is this. That's the intersection of sets A and B. The numbers divisible by 3 or 5, which is the union of A with B, are all of the numbers in either circle A or circle B or both, which means that this represents the union of sets A and B. Some of these elements are in set A but not B, like 9. 9 is in set A but it's not in B. Some of them are in set B but not A, like the number 5, and one of them is in both. And finally, the numbers in the universal set that are not in A or in B are all of the numbers outside of those circles but within the rectangle. In other words, this is the shading of anything that is not in A and not in B. And it's going to get a little more complicated than that because there are other things we can talk about in terms of shading. So this is what you would shade if I asked you what's not in A and not in B. Class example 1 goes through the difference between the intersection of two sets, the union of two sets, and the one example dealing with the complement of set A. So the intersection of two sets I've already talked about. I think it was easier for me to talk about in terms of that example. This is the intersection. Just want to clean that up a little bit. This is the intersection of sets A and B. Anything in this part of the Venn diagram is in set A and in set B. And I would like you to add in your notes that this is A intersect B, or A and B. The union of two sets means it's the part of the Venn diagram that has elements that are in set A, or in set B, or in both. And that means as long as it is within this snowman laying on its side shape, it is part of the union of A with B, which is A or B. So just to make sure you're with me on this, this is A and B. No matter how you cut it, you can write A and B, you can write A intersect B, or you can shade that part of the Venn diagram. This is A or B, which is the union of A with B, or you could shade that part of the diagram. Now, what is the complement of set A? In other words, what is not set A? Well, we can write what it is in terms of notation, I guess. It's just this, A prime. Now, what does that mean? So don't shade anything yet. And by the way, when you're shading it, you don't need a highlighter, but you can just shade it in with a pencil lightly. If I were to look at what is A is this. And what is that telling me? It's telling me that not A is everything else. So if I shade in everything else, that will be not A. So what we're going to shade in here is the following. And I'm coloring outside the lines here. I'm sorry, I was never good at coloring, but I think you catch my drift here. So, whoops, I got to shade in this too, because it's not A. I'm shading in everything except for A. So that is not A. Example 2, we're going back to those sets that we talked about earlier, and we've got a whole slew of Venn diagrams we're going to fill in. And all of the numbers are on here because in some cases I may need to use the numbers to explain things to you. So we're asked to shade a certain thing, we're asked to write the proper notation, and we're asked to figure out what n of a set is. So if I ask you to shade set A, it is going to be this. If I asked you to write down notation that says set A, all I would do is write the capital letter A. And if I ask you, a reminder, and you've had questions in the previous assignment dealing with this, if I ask you what is n of A, I'm asking you how many elements are in A. So how many elements are in set A? 1, 2, 3, 4, 5, 6. So this is equal to 6. What about set B? Well, I think you catch the drift here. This is set B. How would we write set B? We would just put the letter B. And what is the number in set B? We would just be counting how many are within set B. 1, 2, 3. So this is equal to 3. What about set not A? Well, A is everything. A, everybody, is everything within this circle. Inside of that circle. What that means is not A is everything that is not in that circle. If it's in the circle and it becomes A, then anything that's not A will not be in the circle. So this is what we would shade. And again, you don't need a highlighter. Just take a pencil and shade it lightly. And we would write A prime, which means not A. You could write the words not A, but that's not what we're after here. We're after the notation. And how many are not in there? Well, you could count them all. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Or you could have taken the total number in the universal set, which was 19, and subtracted the number in set A, which was 6. Regardless, we get 13. Now, what about not B? Well, we write B prime here. We're also going to figure out what the number in B prime is. I think you should be able to, I'm just changing colors for no particular reason. I think you should be able to figure out that not B is anything outside of B. So anything here is not B. Because the part that I've unshaded, the part that's not shaded, is B. So everything else is not B. The number in that set, I'm going to take a shortcut. I know there are 19 in the universal set, and there is 1, 2, 3 here that are in B. So 19 minus 3 gives us 16 that are not in B. What about the intersection of A and B? Well, really, I've talked about this enough that I believe you should know this. The intersection of A and B means it's in set A and in set B, which means it's where they intersect. That's what the word and means. They've got written there A and B. I don't know. I interpret this a little bit differently. I would think that's the notation, but I guess whether you say A and B or A intersect B, it doesn't matter to me as long as you understand. And there is only one element in that set. So the number of elements in the intersection of A and B is 1. A or B, Well, that would be, see, even here, everybody, I looked at this, and what I said was this. It's kind of like a bilingual situation. Either one of those is good. When you see one, you should think the other. And then, of course, we want to find the number in the union. And we want to shade it. Well, once again, I hope you have learned that the union will be this part. But if not, you just have to remember that the union means in A alone, or in B alone, or in both. So how many are in there? We're going to count them. 1, 2, 3, 4, 5 that are in just A, 2 that are in just B, and 1 that is in both. So that gives us a total of, I think, 8. I better count them again. 5, 6, 7, 8. Yes. Now things start to get a little tricky. What is the set of not A intersect B? Well, I think it's best here. This means not A and B. I've seen people explain this so that you shade not A and you shade B and you look at the intersection. And I'm going to do that right now, actually. If I shade, I'm just going to break out of this view. If I shade not A, it will be the following. Not A will be I'm not saying this is the way to go. I don't like this, but I've seen people do it, and maybe it's because it makes sense to some people. This is not A. You can shade it in a bit more if you like. This is not A. And now I'm going to shade in, whoop, that's okay. I'm going to shade in B. So I've used these lines for not A, and I'm going to use, I'll go blue lines for B, which is this. Now, if this makes sense to you, and you can visualize this, maybe it's just the way my brain is hardwired, this bothers me. Where do these intersect with each other? Where do they overlap? And the answer is they overlap in this region. And this hurts me. This hurts my brain. I cannot visualize this. I mean, I can do it and I can explain it. So that yellow thing is not A intersect B. But I'll save this page just in case I decide that we're going to refer back to it later. But I would not do it that way. What I would do is I would go back to the notion that this is not A and it's B. And for some reason, if I turn that around, it's easier for me to wrap my head around. It has to be something that is B and not A. Well, if it has to be B, it has to be within this circle. But it also, because of the and, can't be A. So in my mind, it's just simpler to say the only elements in this set that are B but not A are these. Now, one way or another, you have to wrap your head around it. And by the way, N of the intersection of not A with B is equal to 2 because there's only 2 elements in here. So similarly, when I look over here, well, this is a little bit different. Let's talk about this. This is A or not B. So here's my thinking. What we're going to do is look at the 4 different pieces of this Venn diagram. There is a piece that is anything in this region. There is a piece that is anything in this region. There is a piece that is anything in this region, and there is a piece that is here. Now, what does A or not B mean? It means A or not B or both. Meaning, if something is A, it's in the set. If something is if something is not B, it's in the set. If something is A and not B, it's in the set. So I'm going to ask you to focus your attention on this region. Are all of the elements in this set A? No, they're not. None of them are A. But are the elements in this set not B? Yes. Every element in that part here, every element here is not B. And that means it's in this set of A or not B. So that's going to be part of what we shade. I want to just clean this up a bit. So we are going to shade this piece. Now, let's focus our attention on this piece. Are the elements in this set A? Yes. Okay, we don't need to go any further. We need to shade that as well. So these 2 regions are going to be shaded. Are the elements in this set A? Well, yeah. It doesn't matter if they're B or not B. If they are A, they are in. What about this region? Are the numbers in here A? No. No. Are the numbers in here not B? No, they are B. So we're going to shade everything except for that region that are B but not A. So everything gets shaded except for this crescent shape. Because everything in any of these shaded regions will either be A or will be not B or will be both A and not B. Finish that off. And then we can count the elements. Well, you know, I wouldn't count these elements. I know there are 19 in total, and there are 2 that are not in the set. And what that means is 19 minus 2 is 17. Not A and not B. Not A and not B. Okay. How would we write that? We would write this and this. Well, we can certainly talk about an intersection, but in my mind, if it has to not be A and not be B, then it can't be either. So what we're talking about here is all of this. Every single element in this set has to not be A, and it also has to not be B. Anything in this region or this region or this region fails this test. Because the item, if we're going to shade it, has to not be A and not be B. How many are in there? I guess we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there's 11. I'll double check. Yep, 11. So n of the intersection of not A and not B is, what did I say, 11? Yeah. What about the union of not A with not B? Well, that means not A or not B or not both. So I call this kind of a test point approach. Is this number, does it make any one of these things true? Yes, it's not A. That is not A. And since it's an OR situation, we don't need to go further with that. We know we're going to shade that region. What about this? Is this number not A? No, it is A. Is this number not B? Yes, it's not B. So we're going to shade this. Every number in here is not B. And that's one of the ORs. What about the 15? Is the 15 not A? No, it is A. Is the 15 not B? No. Is the 15 not both? No, it is both. What about, so we can't shade this intersection part. What about this? Is 5 not A? Yeah. So we have to shade that. And it's looking as though what we're going to shade is everything except for the middle part. By the middle part, I mean the intersection part. Oh, that's an ugly color. So this is the union of not A and not B. Two more to go, I think. What is the complement of the intersection of A with B? This is actually pretty easy, this one. This is not A and B. Well, you should know that A and B is everything within this little oval. Everything inside of that is A and B, or A intersect B. So not A intersect B will be everything else. And finally, we have to count them. Well, there's 18. Guess I should use the right notation. N of the intersection of A and B's complement is 18. And then this, not the union of A and B. Well, you should know that the union of A and B is everything inside of this snowman shape lying on his or her side. And that means that the complement of that is everything else. The notation, what we would write to describe that set, I can write not A or B. And the number that are not A or B are 1, 2, 3, 4, 5, 6, 7, 8, 9, I think 11, but I will double check. The number that are the complement of the union of A with B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I want to skip over something now. There's a point to be made here, but I think this has gone on long enough. We need to get to the examples. I'll talk with you in class about how some of these are equal to each other. Okay, use the Venn diagram to list the elements in each set. So what is in P? P is 1, 2, 8, 9, 10. You know, there's a difference between the number 2, which is in P but not in Q, and the number 1, which is in both. All of these are inside of P. What about the number that are inside of Q? Well, it would be all of these. 1, 7, 10, and 29. What about P and Q? Well, P and Q is the intersection of P and Q. And that would be only these items, 1 and 10. What about P or Q? Well, again, or union means everything inside of this kind of double oval snowman-y shaped thing. So all of these are in P or Q because they are in P or Q or both. So 1, 2, I'm just putting them in alphabetical order, 7, 8, 9, 10. And I think 29 caps it off. (29), not 27. E, not P. Well, this is P. So not P is everything that is not in that circle. 7, 11, 16, and 29. Not Q. Well, I guess it would be everything outside of this circle, which would be 2, 8, 9, an 11, and a 16. Not P and not Q. Well, that means it can't be P and it can't be Q, so the only items it could be are these two, 11 and 16. Not P or not Q. Okay, so I don't think there's anything wrong with this strategy I'm going to show you. Not P or not Q. So I'm going to write this as not P, not Q, not both. If an element makes either of these three statements true, then it's in this set. So is 11 not P? Yes. Is 2 not P? No. But 2 is not Q. So if 2 is in there, so are 9 and 8. Is 1, that I'm going to just circle temporarily, is 1 not P? False. That's not true. Is 1 not Q? False. Is it not both? Well, no. So you cannot talk about 1 and 10. 7 and 29 are not P. So this set includes everything but the 1 and the 10. 2, 7, 8, 9, 10, I think. Nope, not 10, not 10. 2, 7, 8, 9, 11, 29. I'll just double check that. 2, 8, 9, 7, 29, and 11. Oh, and 16. I didn't see that guy hiding down there. Not P or Q. Well, P or Q is everything in here. So if that is P or Q, not P or Q are 11 and 16. Not P and Q. Well, P and Q is this region. So not P and Q is everything that's not in that region. 2, 7, 8, 9, 11, 16, 29. I think, double check. Yep. We're going to skip K because that corresponds to what I skipped earlier, and we have a couple more examples to cover. So now we're going to talk about numbers. This is a Venn diagram that shows members of student council, that's set S, members of the yearbook committee, that's set Y, and then U is the universal set. So you'll notice that none of these numbers have a dot after them, which means they are not elements, they are how many elements. So how many are on student council? 15. Because these guys are on the student council and these guys are on the student council. There's 15 in total. How many are on both yearbook and student council? Well, that's 3. How many are on the yearbook committee but not on the school council? That's only 7. These guys are on the yearbook committee, but they're also on student council. We're asked how many are on yearbook but not student council. So that's 7. How many are on student council or the yearbook? Well, however many are in this, because or is the union. So 12 plus 3 plus 7 is 22. We don't know how many are not on either because we don't know how many are in the universal set. Number 5, in a homeroom of 20 students, 15 take math, 12 take social, and 10 take both. Here is the critical mistake that people make. Here's the mistake. Don't make this mistake. They go, well, 10 take both, so I'm going to put a 10 here. It says 15 take math, so I'm going to put 15 here, and right away, you've killed it. And that's not a good thing. That's not a compliment. Because if you look at what I've written there, I've got a total of 25 in set M, but only 15 take math. So this 15 that take math means everything in set M has to add up to 15, and that means that this has to be 5. How many do I put in for that S part that's still unlabeled? Well, if 12 takes social, I need 2 here. So just to drive this home, this is your 15 in the math. This is your 12 in the social. And this is your 10. Whoops. This is your 10 that take both? How many take neither? Well, there's a total of 20 students, and if we look at what we've got so far, we have 17 students that take math or social. So that must mean there are 3 here. Now let's double check. Do all of these numbers add up to the universal set of 20? Yes. Are the numbers inside of the math circle totaling 15? Yes. Are the numbers in the social circle totaling 12? Yep. And are there 10 that take both? Perfect. So we have one more example. I know this is a long lesson, but sometimes that's the way it works. In a survey of 400 households, I guess that's the universal set, 285 households had some kind of a PVR, whether it was through an internet box, whether it was through Amazon, it doesn't matter. 285 had a PVR, 320 had some kind of printer, and 63 households did not have anything. What we are asked to do is essentially find out how many households had both. So I want to cut to the chase here and tell you that this is going to walk you step by step through something, but we want to determine how many have both. And I'm going to start by telling you that when you see a question like this, you put X in for both. Now, what are you told to do here? I've got the numbers at the top of the screen. The universal set is 400. The number in set P is 285. The number in set M is 320. And the number that do not have a PVR and do not have a multifunction printer is 63. That means, by the way, the 63 goes here, and we have answered A. Write an expression for the number of households who have a PVR and not a multifunction printer. Well, what we're asked to do is find an expression for what's in here. And that is going to be the 285 people that have a PVR minus however many have both. You really have to think carefully about this. The number of people who have a PVR but not a multifunction printer are the number that have a PVR minus those ones that also have the multifunction printer. So we're going to put 285 minus X here. Write an expression for the number of households who have the printer. Well, 320 have a printer. But some of those 320 also have a PVR. And we need to take away the number that have a PVR to get the number that have just the printer but not the PVR. Now, how does this help us find X? After you do a couple of these, you'll like them. They're pretty simple. All of these things added together, everything here added together, this, and this, have to give you 400. Because there's 400 items in the universal set. There are 400 people in 400 households that were surveyed. So our equation will be 63 plus 285 minus X plus the X plus the 320 minus X equals 400. And what's always going to happen in these questions, just going to move this to the top of the screen where I'm not bending over, is the X's will collect together to give negative X. I mean, look at the X's in this equation. I have negative 1x plus 1x, which reduces to 0, and then I have that negative 1x left. So now I'm going to add some numbers together. With my calculator, because it's getting late in the day for me to do mental math. I'm going to figure out what that 63 plus the 285 plus the 320 is. I get 668. So 668 minus x equals 400. If I add x to both sides and subtract 400 from both sides, what do I get? I get x equals 268. So now we're going to do some checking here. I'm going to put the number 268 here. I'm going to take 268 away from the 285. $285 minus 268. To get 17. I'm going to take 320 minus 268, and that's going to give me 52. I'll just double check that. Yep. So what we have is this many in this region, this many in this region, this many in this region, and this many in this region. And if we have the right answer, those four blue numbers have to add to give the number in the universal set. So 63 that have neither, plus the 268 that have both, plus the 17 that have the PVR but not the printer, plus the 52 that have the printer but not, the printer but not the PVR, gives 400. And there's something oddly satisfying about that, that when you take a look at everything we've done here in this problem, it worked. Now, when I see you in class, and there are only two or three of you that are enrolled, I'll have to check in the morning because my numbers might have changed. I'll sit down with you and show you an alternate way that I don't like, but you might. Anyway, I know that's a long lesson, but we had to get through it. And tomorrow, in the next lesson, we'll be looking at Venn diagrams that involve 3 sets. So I hope you're able to follow that. Take a look at the questions number 1 to 12. That's your practice before you move on to the next lesson. In the meantime and in between time, that's it. We'll talk to you later. Take care.